All right, it's 9 o'clock Central Time and 4 p.m. Barcelona time. So we're going to go ahead and get started here. Hello, everybody. My name is Matt Delacluse. I'm the General Manager with RAECO Rents. I'd like to thank you all for taking time out of your busy schedules to join us for the Electromagnetic Field Measurements for Radio Frequency Safety webinar. Our presenter today is Aymen Jemni from WaveControl. In this 45-minute free webinar, he will cover the following. Introduction to electromagnetic fields, regulations and standards of EMF measurement, why, when, and how to take measurements, applications for EMF exposure monitoring, what can you learn from a spectrum analyzer, choosing the right probe for your application, and then we'll have some questions at the end. Aymen Jemni is a senior application engineer at WaveControl, where he provides training and technical support in electromagnetic fields measurement equipment. He works closely with research and development engineers, sales teams, and customers, providing technical support to clients, helping improving production capacity in existing EMF meter solutions, and responding to inquiries with sensor engineers and project managers. Prior to joining WaveControl, Aymen was employed by the Microelectronic Institute of Barcelona as an analog microelectronic design engineer, where he was responsible for the introduction of new design methodologies for providing system test planning and implementation. Because a large number of attendees will be muting the phone lines, if you have any questions, there's a chat tool built to the GoToWebinar. Please enter your question and we'll make sure we get it answered. Now I'd like to turn the microphone over to Aymen. Welcome.
Hello everybody, welcome to this presentation about electromagnetic fields for radio frequency safety. I thank you, Matt, for the introduction. Then I will start my presentation, and I will, as you explained before, it will be a brief introduction to WaveControl, our company, to a brief introduction to electromagnetic fields and regulation and standards. Then we will focus on sectors, in which sectors workers and public are exposed to EMF, and the solution that WaveControl offers. For those who are used to use some equipments for the EMF measurement, I will end with some benchmarking, comparing WaveControl solutions to others that already exist in the market. And to start with WaveControl, we are a company from Barcelona in Spain. We exist since 19 years. We have already delivered more than 2,000 equipment worldwide in more than 40 countries in the 5 continents. And we have the ISO 9001 certification company, but also, which is very important to make professional measurements, we have an accredited lab with the ISO 17025, which is the main accreditation for the calibration of the EMF equipment. Because many standards ask that the equipment to be used for the measurement had to be calibrated following this accreditation. And we have a continuous research and development lab. We are always improving our solutions with new functionalities, but also with new equipment and new solutions in general. We cover many countries worldwide in the 5 continents, and this is some photos of our solution that I will introduce it in more details later. Then just to give you an idea, this photo shows the electromagnetic spectrum in the description of the electromagnetic radiation sorted by frequency. We can divide this spectrum into 2 parts, the non-ionizing radiation part and the ionizing radiation part. The non-ionizing radiation part, it's what we call electromagnetic fields, and it's radiation that does not carry energy to ionized matter. But the electric and magnetic fields occurs naturally within the body in association with nerve and muscle activities. As you can see in the photo, depending on the frequency of the there are many applications that we are used to be next to it, and where people and workers are exposed to EMF. Just to give you some idea about regulation and standards, I have chosen two famous institutions: ICNIRP, which is the International Commission for Non-Ionizing Radiation Protection, which is recognized as an unofficial collaborating non-governmental organization by the World Health Organization. ICNIRP is consulted by many organizations, for example, like the European Union, like the OSHA in the States, and many other organizations engaged in non-ionizing protection. ICNIRP provides scientific information and science-based guidelines on protection from EMF through a wide range of publications and guidelines. The Congress of the United States of America, for example, created the OSHA, which is the Occupational Safety and Health Administration, to assure safe and healthful working conditions for working men and women, enforcing standards and providing trainings. Both ICNIRP and OSHA conducts research and make recommendations to protect general public and workers from proven and possible EMF health risks. Just to give you an idea where general public and workers can be exposed to EMF, this table summarizes a list of application and sectors. As you can see, it covers industrial application in general. It means all the industry where it's used electric heating, induction heating, all the industry where that use welding machine, all the systems with detection of articles and people, like RFID detection, etc. The traditional sector of energy production and distribution, like electricity, etc. Also the transport and traction systems, like trains, metro, etc. The famous and also traditional sector of telecommunication and radio, TV broadcasting, and many other applications like households application or medical application. As you can see in the next to each application and sector, there are one or more standards. These standards, we will see some examples in the next slides. These standards explain how to measure or calculate the exposure of the public or of the worker, depending on the sector. What it means depending on the sector, it means also depending on the machines or the frequency range of the emission of the EMF. This frequency range can be considered as low frequency or high frequency. Usually low frequency, it's what we call between DC or 1 Hertz till 10 megahertz, and high frequency it's from 10 megahertz till 300 gigahertz, which is the limit for the spectrum of non-ionizing radiation. And these standards, depending also on the frequency range of the radiation, asks to use some different kind of equipments that I will show you later. Like it asks to do some broadband measurements, which means a measurement in a large interval of frequency, and then have just one value for all this frequency range. Or sometimes it asks to do some selective measurements. The selective measurements permit us to know the level of the radiation for each frequency. As an example of this standards and sectors. As you can see, EMF can be present in industry, in telecommunication, in energy sector, in railway, in medical, labs, aeronautical, everything related to worker safety. This is some examples of some normatives that explains how to do the assessment. These normatives who usually are written by some institutions in the States, for example, the IEEE, or in Europe and worldwide by the Senelec or the IEC. It gives you the procedure for the assessment. This is, for example of basic standard, general standards for human exposure in general or for workers' exposure in general. For example, there are also important standards that defines which equipment has to be used to make these measurements, because in the market there are many equipments, there are professional equipments, but there are also low-cost equipments. Later in the benchmarking part I will show you a bit the difference between our solutions and what exists in the market. For example, for telecommunication and broadcasting sectors, there are many normatives also. He gives you information when, where, and how to do the measurements, for which frequency range, and how to compare with the limits, etc. If we took, for example, the energy sector, we have also the EN IEC 62110, which explains in details how to make measurements. All these normatives that I'm showing you now are available, but it's available for per case. I mean, all these institutions, this international institution, they sell it if you want further details. Also for the transport, there are specific standards because, for example, the driver of a train, of a metro, is during several hours every day next to telecommunication equipment where he communicates with central, and also he's behind power lines that emits EMF. And for the worker safety and also for public safety, by law in many countries, the customer has, or the responsible has, to make measurements. This is an example of also of some normatives for machineries that exist in industry in general, like for welding or for heating. Just to give you an idea about the frequency range of these machines, you can see, for example, usually the smelting machines are working at low frequencies, which could be at 50 or 60 hertz, at 2 kilo, 10 kilo, etc. For induction heating and electric heating, it goes to some higher frequencies of few megahertz, and depending on the application, depending on the machine, the frequency of the emission may change, and then the equipment to be used also has to be different. In hospitals and medicine, or in medical applications in general, also doctors or nurses, etc., are always working next to some machines that the emission are high, and usually hospitals, they have to make measurements for their work safety and also for public safety. Not all the countries has laws that oblige the owners of the hospitals and clinics to make these measurements, but usually they just do it by themselves, or they ask an external lab to do it for them. At WaveControl, we have several solutions for punctual measurements and also for continuous measurements. I will show you the main instruments used for punctual measurements, which is a handheld meter. This meter is unique as it is two instruments in one, as it's capable of making broadband measurements covering with several field probes from 1 Hz till 18 gigahertz, but also it makes a spectrum analysis covering from 1 Hz till 400 kilohertz, which are the main frequency in low frequency applications. All the field probes used with the SMP2, this meter is called the SMP2, are isotropic and RMS. Isotropic and RMS, it means that the probe can detect any radiation in all the position. I mean, it has 3 axes, X, Y, and Z, and even if you move it from top, right, left, etc., it will detect the radiation and give you the result of the measurements. This unit, the SMP2, also permits to have a time assessment. It means comparing the result to a limit. There are several limits depending on the normative that you will follow, that you have to compare with. In the States, for example, you have to compare to the IEEE 95 or to ICNIRP, but also in other countries like in Canada, you have to compare to safety codes, in Europe to the 2013 directive, etc., etc. And the SMP2 uses the weighted peak method, which is the most precise method or the most precise technique, allowing to check compliance with all the limits for both electric and magnetic fields. The SMP2 has an integrated GPS, because in some sectors you have to when you write your report, you have to say in which place, in which coordinates you have done your results, etc., like in telecommunications. The SMP2 has a graphical display in color in real time. This graphical display helps to obtain a quick overview on the field. It has a screenshot function, which is very helpful for the report, for the final report that you will generate. You will have a proof, a screenshot of your measurements. The SMP2 can be connected to software that we provide with it through USB cable. This USB cable is mainly for downloading the measurements, but also it can be connected through fiber optics, which is mainly for remoting control the unit, because the presence of a human body next to the equipment may interfere in the measurements because of the physics laws, and then many standards suggest to use a fiber optic connection to remote control the equipment and make the measurement by distance. The SMP2 has an upgradable firmware. Our engineer team always, almost every month, 2 months, adds new improvements in the firmware of the unit, and these new firmwares are totally free. We send it always for free to our customers. We are always open to the suggestion of our customers in order to add new functionalities, etc., etc. This is the presentation of the field probes that we dispose at WaveControl. For high frequency measurements, broadband high frequency measurements, we have field probes that covers from 100 kilohertz till 3, 6, and 8 gigahertz. We have another one covering from 300 kilohertz till 18 gigahertz. This is mainly for measuring the electric field. In high frequency measurement, usually we are what we call in far field conditions. Then electric field and magnetic field, they are proportional. Just measuring one is sufficient to have the value for the other. We have also a special probe for just mobile bands, GSM, UMTS, and LTE. And we have a probe just for measuring magnetic field for higher frequency, starting from 300 kilohertz till 60 megahertz. And we have two probes for measuring low frequency, the WP50, which covers from 10 hertz till 3 kilohertz, and it's for both electric and magnetic field, because in low frequency usually we are in near field conditions, and in that case the electric field and magnetic field has to be measured separately. We have also the WP400 probe, which is one state-of-the-art of what we have at WaveControl. We have it since the end of 2014. It covers from 1 hertz to 400 kilohertz for both electric and magnetic field, but it's a probe, it's a selective probe, which means that you can do several kind of measurements, not just broadband measurement using this probe. Just to summarize, high frequency probes in general are used to make measurements in telecommunication, in microwave application, in defense, airport, medicals, etc. Because mainly in these sectors the radiation comes from higher frequency. It permits to measure electric field and magnetic field in far field conditions. And the measurement method, it's broadband measurement, and of course it's RMS, as all our probes are RMS and isotropic. The WP400, it covers the main applications for low frequency. It means for 1 hertz till 400 kilohertz, and it measures separately the electric and magnetic field, but both sensors are integrated on a single probe, and it permits to make 4 different kind of measurements in the same moment, like broadband measurements, FFT for spectrum analysis, like to have the field level for each frequency separately, depending on the span that you choose. Also, it permits to make a single log frequency in time. I mean, for example, if you are interested in measuring the field at 60 hertz in time, how it changes in time, for example, next to high power line for electricity distribution, this is possible. And also it permits to make weighted measurements comparing with a large list of selectable limits using the weighted peak method, which is the most precise and the most suggested method by many institutions. ICNIRP is the institution who created this method. The SMP2 reader is delivered with a software, called SMP2 reader. The SMP2 software permits displaying measurements in graph and table format, display the stored screenshots, the information about your unit, and also remote control the SMP2 for live measurements when you are connected with fiber optics. All the measurements that you have in the SMP2 can be exported in a very easy way with the screenshots related to this measurement to an Excel files. Also, it's possible to send the measurements directly to a web server that I will show you later, which is related mainly to another solution, but also it can be related to SMP2 reader. The second unit we offer at WaveControl, it's called MapEM. It's like monitoring of electromagnetic fields. It permits continuous EMF monitoring, and it's autonomous. It can work with solar panel for battery power, but also there are AC version and AC/DC version. It could be connected directly to the plug, to the AC connection. It permits continuing monitoring of EMF 24 hours all the days of the year. It's very robust to rain, to heat, to sun, etc. It has IP66 environmental protection. It can be applied in many applications, but mainly in telecommunication, in TV, radio, broadcasting, and also measurements of next to high power lines. This unit has been developed by WaveControl in accordance with a recommendation of the International Union of Telecommunication, which is the ITU-K 83, which recommends to make continuous monitorings of EMF, not because the levels are always high, no, just to have a control and to be sure that no harm will happen to the worker or to the general public. It's very easy to use the MapEM. It has to be installed just in front of electromagnetic field source, and the data will be sent through a modem to a control center, a server, where it gets the reception, recording, and the analysis of the data. The data, this is a screenshot of our control center. I mean, you have information about where your units are, the MapEMs, your units for continuous measurements are installed, and when you click on one, you have a graph, a live graph about the EMF levels. You can filter the graph by date or by position. This is some photos of some MapEMs installed next to BTS antennas or to high power lines. We have also another solution that we call compact MapEM, also for continuous EMF monitoring. It's more for indoor monitoring, and it's used mainly for mobile bands and Wi-Fi measurements indoors. It can be also installed in the street, and it has also an integrated GPRS 3G modem to send the data to the control center. Another solution that we offer also for some special customers who asks to, mainly in military sectors or governmental sector, which they ask to make a map of electromagnetic fields. I mean, this solution, it's very similar to the MapEM, and it's installed on the top of the car, bit similar to Google Car, and it goes on all the road of an area. It could be a city or what else, and it gives you a map of the electromagnetic fields, and it locates the warm areas. It's very easy to set up. I will finish with some benchmarking. First of all, as I said in the beginning, the SMP2 is a two-in-one equipment, mainly in all our competitors. If you want to make broadband measurements, you need to purchase a unit for broadband measurements. If you want to make selective measurements, you have to purchase a unit for selective measurements separately. The NBM 550 from NARDA, it's a unit for broadband measurements. This is what you see here, some advantages of the SMP2, as the SMP2 has a display light sensor, means when you make measurements during the day, outdoor, etc., it will be very easy for the engineer or the person responsible for the measurements to read the measurements. It has integrated GPS, while the NBM has an external GPS. It has the screenshot function. Very user-friendly interface, color screen. The NBM has voice recording. They have it can be connected to probes till 60 gigahertz. At WaveControl, till now we have probes till 18, but soon, really very soon, we will increase our frequency range also in probes. And the SMP2 can be like the NBM for broadband, but also the SMP2 can be used with the WP400 probe for low frequency measurements. For example, NARDA again offers the LT400, which is the main equipment for the measurement of magnetic field in low frequency for NARDA. But the FFT for the SMP2 is integrated on the screen. The WP400 probe, it permits measuring both electric and magnetic field. The ELT only the magnetic field. The SMP2 can be controlled by using the fiber optic connection to remote control. The ELT400 cannot, and as I said again, the SMP2 is the state of the art since 2015. Both NARDA and WaveControl have professional equipment for measurements, but WaveControl, the solution that has been now, offers much more functionalities and for a lower price than NARDA. I wanted also to compare the SMP2 to what we call low-cost equipments like the Index 2 or Aronia or etc. The main advantage of the low cost is the price, except that they have no advantage because they don't have isotropic probes, and all the list of the normatives, depending on the sector that I showed you before, asks to make professional measurements using isotropic probes. The SMP2 is fully compliant with standards. It used weighted peak evaluation method, FFT, etc. The low cost, they don't do it. The SMP2 measures both electric and magnetic field for low frequency. The low frequency, the low cost equipment like Index do not, etc., etc. And I will finish with comparing with the Microrad. Is another competitor of us. Microrad also offers equipments for the measurement of EMF, but they offer different and several field probes. It means if you want to measure electric and magnetic field, you have to purchase two different probes. They don't have the time domain analysis using the weighted peak method integrated. They only make broadband measurements. If you want to make weighted measurements, you have to connect the NHG in that case to PC and using a software, etc. But in the field with the SMP2, you can have your weighted result directly on the screen to have an idea. We have the SMP2 has the analysis on meter and screen on graph display. Also, at WaveControl, this is a big advantage compared to our competitors. All our field probes are calibrated following the ISO 17025. Our competitors, they offer this calibration as an extra with an extra price. They always offer what they call local calibration or factory calibration, which is not the calibration asked by the majority of the normatives that shows you how and when to measure. Thank you for your time. I hope I respected the time. I'm waiting for your questions if you have any. And I give the word back to Matt.
Aymen, thank you very much for the presentation. We do have a couple questions here.
Yeah.
One was, is the SMP2 intrinsically safe?
Sorry, again, can I?
Yeah, intrinsically safe would be, can it be used in explosive environments? So,
in explosive, yes, it is safe. We have already had this question for a customer that purchased it for us later, because it was Airbus. The company was Airbus. They purchased from us, and yes, because we have a certification from the one who gives us the batteries, because the main danger comes from the battery, and it's safe. Yes, it is safe.
Okay. Let's see. Here's another one.
Yeah.
Other than the EN standards, can you recommend any publications addressing worker exposure, evaluation, and health effects?
Again, the first part, I didn't hear it well, please.
So, other than the EN standards, can you recommend any publications?
There are many publication available, but I didn't understand the first word. EM what? EMC, he said.
I don't know, maybe EU standards or is it English? I'm not sure. We'll have to ask for clarification and maybe get back here.
Yeah, please. I can respond to any question if you send it to me. But is that I didn't understand the EMC, but there are many papers and many recommendations, and that explains how to do the protection, how to make the measurements, etc. The most famous institution is the ICNIRP. But also there are some publications from WHO, the Health World Organization, and depending on the country, also there are, for example, in the States, there are many publications from the IEEE. If he tells me in which sectors he's interested exactly, I can send you by email the name of this publication and standards, and you can pass it to him.
Okay. All right, let's see, here's a couple more. Measuring of EMF above 50 gigahertz, is there a meter to measure to 75 gigahertz? Will WaveControl be looking to provide equipment to measure this range?
Till more than 75 gigahertz.
Yes.
Yeah.
Measure to 75.
Sorry, again?
They're looking to measure to 75 gigahertz. Will WaveControl be providing a probe?
We are working on new probes, reaching for the moment till 40 or 50 gigahertz, but also 75 could be in our agenda. Maybe not very soon, but it could be in our agenda. I will send you some information about that, Matt.
Okay.
But yeah, it's possible. We have the
yeah, there was another one too asking to measure between 70 and 80 gigahertz.
But
people out there
which application is that? Is it related to radars?
They don't list an application. They're just looking for
okay.
70 to 80 gigahertz range.
70 to are they listening to my answers now? Yeah.
Yes, they are,
yeah,
and we can always
because I'm interested in which application between 70 and 80. Is it related to radars? Because there are very few applications at this frequency. It's for that.
I don't know. We'll have to see if I don't see a response at this.
We can get a name. So
yeah, we've got the names and the questions here, so we can always respond back again later.
Okay.
Do you make personal RF monitors with alarms?
We are now. Hope soon we will have personal EMF monitors. I mean the personal, the one that the worker can have it on himself all the time. But also we have another solution. It was not presented now because the time was not long. That we call MapEM Lab. It's a solution that can be installed inside a laboratory and to monitor in continuous also, and has Ethernet connection that can be connected to PC through software using Ethernet. And if the EMF level reaches some limits, it generates a audible and light alarm. But this solution mainly is to be used indoor, I mean in laboratories, etc.
Okay. Next question would be, are there standardized procedures available for taking measurements?
Yes, but depending on the sector.
Okay.
I mean, depend. For example, if you are interested in public safety in general, first, it depends on the sector. Second, it depends on the, if we know the sector, we know the frequency range. For example, just to give an example as everybody is listening, ICNIRP asks that for high frequency, mainly for telecommunications, the measurement should be done on 6 minutes. The scientific studies done by ICNIRP said that if we calculate the average of a measurements on 6 minutes, we can compare this value to a limit. If we measure it in 1 minute or less than 6 minutes, it won't be as much as precise as suggested by scientists.
Okay. The next question is regarding RF health surveillance. When to test employees, and are there any recommended biological tests?
There are many recommendations, but usually it depends on the country. The OSHA, for example, in the States, if all the customers are from the States, has published some publication about that, about how and when to do this kind of measurements for worker safety.
Okay.
But also, there are many standards available for that. Again, I can send to you, Matt, the name of these standards for protection of workers in general. And if your customer tells me in which sector, I can also send him the name of the standard for this sector, or the standards, because there are several.
Okay. I've had a couple comments on the finding documents here. One person says that AIHA has some very good publications on microwave and radio frequency HNS. Also, the NCRP also provides guidance in the U.S. So there's a couple responses to that question. What is the average battery life for the SMP2 when performing field work?
Hard question. I'll explain why, because it's state of the art, but for sure between 4 and 8 years. This is for sure.
What about run time? What do you get on a charge? How long does it charge?
Making broadband measurements, minimum 14 to 15 hours. And using the WP400 field probe, it means doing selective measurements. It's around 5 hours, because the SMP2 has a microprocessor integrated on it to make the selective measurements in real time and also the weighted measurements in real time, and then it consumes more energy, and then the battery may. Yeah, around 5 hours. But for broadband measurements, it's minimum between 14 and 15 hours.
Okay. Can the meter be used for measuring RF leakage from semiconductor equipment?
Yes, but also then it has to be purchased another solution that we also offer to measuring DC, because depending on the semiconductor industry, depend on the machine, but mainly it's low frequency. But yes, yeah, it's possible.
Okay. Sounds like the people who are looking for above 50 gigahertz are looking at 5G technologies and radar.
Yeah, it's 5. It's for that I said it's radars. Anyway, I will ask also this question to our R&D department, and I will let you know with more details.
Okay. So if a meter is running and the batteries run dead, what happens to the data?
It stays. The SMP2 has a special function for the protection of the data. If it detects that the battery is almost empty, then it stops writing on the internal memory card to protect the data. And the internal memory card, it permits registering more than 1 million samples, which is much more than 1,000 measurements or more. Okay. It won't be full. Yeah.
And the last question I have so far is the was 50499 mentioned in your presentation. He was wondering if there's
Yeah.
any peer review reference of that written in English.
It's written in English, but I don't understand by review.
He's looking to see if anybody's done a peer review on it, on that standard.
I don't know really, but this is one of the most famous standards worldwide. It's followed by many people in many countries. I can send him a summary of these standards if he's interested.
Oh, I think that's it.
Yeah.
All right. All right. Well, if you have any specific questions, feel free to give me a call. I'm at 866-RENT-EHS or 866-736-8347. You can reach me by email at matt@RAECO Rents. That's RAECO Rents.com. Let's see. If you want to know more about the technologies we supply, please follow us on social media. We put out lots of good technical tips on our blog, blog.raecorents.com. You can also follow us on LinkedIn and Twitter. We do record all these training sessions, which you can find on YouTube, so we'll have this one posted shortly. If there are some topics you'd like us to cover in these webinars, please send us an email with the subject. We'd be happy to look at doing those. Let's see, we have access to lots of product and process specialists. Please let me know if we can help you in any way by emailing me at matt@raecorents.com. Next month we have another webinar topic. Sensodyne's Bob Selwyn is going to cover Vibration Monitoring 101. And let's see. And this will be on Halloween, October 31st, our treat to you at 9 a.m. Central Time. At this point, if there are no further questions, our presentation will conclude. But I think
we have one more.
We have one more. It said, we have all trusted NARDA for decades. How do I convince my clients to use WaveControl?
It's very easy. We can deliver you a demo unit that you can leave it for your client for some days or 1 week, and he will be convinced by himself that WaveControl is as good as NARDA. But also another thing is that, as I said, in WaveControl we have a very good team working for the needs of the customer. If your customer has special needs, we can work on it to add it in our firmware of the unit, etc.
All right, we've got another question here.
Yeah.
We got to piece it together a little bit.
What was it, Eduardo?
Yeah. Here we go. I'll read it out loud. RF Health.
So Eduardo started with the question, RF Health surveillance, when to test employees, any recommended biological tests. He says the sector for my previous question is general pharmacy industry, specifically PVC bag sealers.
PVC bag sealers.
I don't know, we may have to still take this one offline,
Yeah.
we can, Eduardo, we can contact you to get some more specifics on this and get you in contact with Aymen to get any of these questions answered for you.
Okay.
All right.
Let's see if there's anything else here.
Let me just make sure we don't have any other last-minute questions here, and then we'll just wrap this up. Think we're good?
Yeah.
Yeah.
I think we're good.
That would be it. We thank you for attending.